All right, so you set up your, you don't have to go by the same intervals here, but realize your intervals do need to be consistent. If you decide to go by 5s, you can't all of a sudden stop and then start going by 10s. Sorry, folks, that's just right out, okay? So set your interval up and then stick to it, and then draw a bar that represents how many 50-cent items you sold, right? So here's your first bar, up to 32, that's about right. And then our $1 items, we sold 24. That's about 24. And if you've got graph paper, folks, you can tell a little bit better what's going on. Which is why graph paper is generally better. You don't have to, okay? It's not mandatory for any of this homework assignment, folks. But realize that, I mean, here's 12. That looks about right. And then $2 goes back to 32. Perfect. So there's our bar graph.
I think I can handle that.
Now, if I asked you to draw a line graph, what would you do instead? You would put dots right here, and then what would you do with the dots? Go back and do your kindergarten dot, okay? I'm assuming I don't need to do an example of that?
No.
Okay. Now, the only problem with this graph, right, is that what's missing? Okay, well, true, I should have put a title in here that sales, something along those lines. But what else is, what from the data is missing? The items, right? I have the dollar amount, which is important, right? I mean, obviously the dollar amount is important. But management probably wants to know what those items are, because middle management, they don't know what we sell things for. The management, they don't go out into this, out into the actual fair and sell stuff, do they? I mean, come on. They walk around with like fancy clothes on, and they sip their fancy coffees, and they're like, oh, let's discuss money. Thank you. Do they do anything? No, that's middle management, right? They don't do anything. They just stand around and make you work. That's their job, right? And then when it comes time to say that we don't need you anymore, it's their job to do the, that's what middle management's for. Alright, so anyways, middle management needs to know what these items really are. How are we going to let them know? Add a side note, or what we call it in biz, a legend. Yes. So when you have more information, you have to somehow let them know that you have that information. Now, in theory, if you wanted to, next to the 50 cents, you could have written candy bars, and next to the $1 written sodas, right? And next to the $1.50 written a pretzel, and next to the $2 written an ice cream, and that's perfectly acceptable. There's nothing wrong with it. Then you have at least given me all of the information, and that's good. But generally speaking, you don't want to put 2 pieces of information along one line of your graph. That's considered poor form. It's okay. No one would get mad at you. But they kind of look at you and go, really? Really? Come on. So what they would really like, of course, is a legend. Now, how are we going to let them know that the 50-cent item was really a candy bar? Now, what we did what we used to do in the early 1980s, 1990s was we would put different colors inside of our bar graph, and then in our legend we would say that red represents pretzels, green represents blah blah blah. Why don't we do that anymore? Yeah, because there's too many colorblind men out there, right? This is men, folks, right? We're the problem. I mean, on many levels.
I used to have a manager about 10 years ago that was colorblind, yet he made all his floor charts in the restaurant I worked in.
Color.
Each section was a color. But then he
wouldn't know?
He wouldn't know. He would just put our names there, and then all of a sudden somebody would say, there's a table in red that hasn't been picked up, and he'd start yelling at 2 or 3 different people because he didn't know which person it was. It's
See?
ridiculous.
So what you have to do is come up with a new schema other than colors, okay, folks? And, you know, you can be boring if you want. You can say, my lines here have nice horizontal lines in them, so then you'll say, oh, over in my legend, this represents, what were those again? Candy bars. And if you're still being boring, you can put vertical lines.
Yep.
I mean, that represents, what are those? Sodas. But if eventually you start to feel adventurous, you can be adventurous. This is picture drawing time. Have fun. It's math, folks. You don't get to have fun very often. So enjoy it. So if you want, put in, question marks. Be creative, right? So things with a question mark in it, those are, yeah, because we don't know what a pencil is. So we use question marks. So we don't know what to spell. Whatever. Right? And then if you want, right, then once you start feeling goofy, then you start getting carried away. So you put in smiley faces. Or frowny faces because you don't know what a pencil is. Whatever. And your smiley faces, those, what was the last thing?
Ice cream.
Ice cream. So just don't forget to give the person, whoever that person is, whether it's me on the test, a manager at a particular company, all of the information that's associated with the picture, okay? And again, you could put the names down here, but it's just, again, the livelier a graph is, the more important you look. Yeah, because you could, I mean, certainly you could have these lines be red and these lines be blue and the question marks be, you know, like bright orange and the smiley faces be fuchsia. I mean, whatever, right? Then you can have color and you don't have to worry about the colorblind people not knowing what's going on. Alright, so again, just make sure that you give me all of the information. I don't need to do another bar or line graph, do I?
No.
I really just don't understand what a line graph is. Can you just say it again? You don't have to.
The difference,
Yeah.
a line graph, you put a dot there, a dot here,
Oh, okay.
a dot here, and a dot here,
And
Like
just
connect the
draw it.
dots.
Gotcha.
hence line graph.
Okay.
So same concept, just lines as opposed to bars. Again, lines aren't quite as exciting because you can't get the nice legend going along with them. It's kind of annoying.
We're not gonna do trends, are we?
No. Alright, so we can have line graphs, we can have bar graphs. Guess what other kind of graphs we can have? Pie graphs, of
Oh,
course.
yeah.
We need to have pie charts too. Come on, we've already been doing sodas, ice cream, pretzels, and candy bar. We got to move into pie. All right, so pie charts. The book spends an inordinate amount of time trying to tell you what the angle is of a piece of pie in the pie chart. Folks, I'm not going to ask you about that, okay? So don't worry about it. It's interesting if you want to read it, but I really don't care, okay? Just so you know. Alright, so. That's a pretty good circle for me. Alright. So, let's assume that I decide to draw a pie graph for my sales. Salsa for sales. Okay. I haven't had enough coffee yet. Well, that's not true. I probably had too much. Yeah, probably not. Okay, so let's imagine, if you will, that I drew a pie chart for my sales. And let's assume that 25% of my sales were in... Let's move away from the candy and stuff. I'm already hungry enough as it is. Let's go back to furniture. So, 25% of my sales were chairs. 20% of my sales were in desks. Let's go with, let's see, that's 45, so let's go with here. Say 15% of my sales were in lamps. What am I at, 60 so far? So then let's go with, let's say that 35% of my sales were in, what am I missing? Tables, okay, tables. How much do I have left here? 45, 60. 5%? Okay, so let's then.
That's a big piece of 5%.
Yeah, we should probably make that 30%, 35% a little bit bigger. And that's actually points out a point, right? Here we go. And then 5% were for miscellaneous items. When you're dealing with pie charts, folks, if the words can't fit in the piece of pie, don't just make the pie bigger so that they fit. That I had actually had a report where someone did that. They had this humongous pie chart because one of the words was like automotive sales, right? And so they had to have the word automotive in the chart, and instead of having a line outside of the chart with the word automotive in there, they made sure the word automotive fit in the chart. And then everything else was like, abbreviated, spark plug, and, Really? Yeah. Okay, so, don't, just remember you can do this. Alright, so, let's say that my sales were, let's go with, what do you think? How about $4,000? So my total sales were $4,000. And these were the percentages for each one of the different items that I was selling. Used furniture. Those work and save pennies. Good ones. Alright, so, how many dollars in lamps did I sell? So the reason that I like pie charts in this particular class is that all of our pie charts are based off of percentages, and what have we been doing almost this entire class? Percentages, over and over and over again. So please guys, be aware that this is what I'm going to care about on the test way more than I'm going to care about this stuff, okay? You're going to have to do some bar charts and some line graphs on the homework, but really, working with pie charts is more along the lines of this class, because pie charts are percentages, and that's kind of the focus of this class. Alright, so be ready. Anyways, how many dollars in lamps did I sell? How'd you figure that out? She took 15% of $4,000, right? 0.15 times 4,000. I sold $600 in lamps. Woohoo! What percent of my sales came from desks? Guys, if I give you a freebie, don't freak,
Take it.
just take it, okay? I mean, if all you have to do is read the number, just read the number, okay? So yes, you can, if you want, figure out how many dollars in desks I made in sales, but did I ask for that? No, and if you gave me that number without telling me that it was 20%, you're actually going to lose points, because you didn't answer the question. Right, so don't presume that you know more about what I'm asking than I do, okay? If it sounds silly, answer it correctly. Alright, so. I discovered I made an additional $500 in sales on lamps. So after I filled out this report and created my pie chart, I was like, oops, I didn't grab all of my sales slips, and I realized that there was a separate box that we put all of the fancy lamp sales in. I didn't know about it, right? Because all I did was sales, and someone else filed all of the sales receipts, and so when I had to go and add them up, because we didn't have a computer, folks, we had one of those old school, you punch it in and you things, right? it wasn't quite it wasn't quite, you know, an abacus or anything like that, but it was pretty damn close, all right? So, what I want to know is what percent of my sales were from lamps. So in other words, how did my total sales in lamps change because of this additional $500 that I found?
Find the percentage and then add it to what you got up there.
Find the percentage and add it to what I have up there? How would I do that though?
500%. 500. What is $500? What's the percentage of 4,000? So it's 12.5%.
But wouldn't your total be 4,500 now? Yeah.
Oh.
Gotta be careful. How do you figure out percentage again? So if I want to know what are my percentage of lamp sales, how do I figure it out? What's the numerator? Sales in lamps, right? And what's my denominator?
Total sales.
Total sales, right? Lamp sales over total sales. So how many sales did I make in lamps? Whoa, wait, 1,100. I don't see the 1,100 up in here. Where'd you get that from?
600, 500.
That's why I made you do that one. So that you know I did have 600 in there. Oops, I found an additional 500. Sweet. 600 plus the 500. Now I made $1,100 in sales in lamps. What are my total sales now? Yeah, there's where, this is why you can't just add the percents, because you actually have changed the total amount of your sales by adding in the 500 bucks. So, what's 1,100 divided by 4,500? Round it, say to the nearest percent, that's fine. Which is approximately 24%. I like those sorts of problems. Do not be surprised when you see something like that on the test. All right, so. Oh yeah, we would have to redraw the pie chart too, technically, right?
Yeah.
How would the pie chart change? How about if I just asked you to describe it to me in a sentence? Wouldn't that be an awesome math question? What changes in the pie chart?
Everything.
Everything. How does everything change?
Because it's all based on 100%, so everything else, the percentage will go lower.
Right. Everything else will go lower, and lamps.
Go high.
Right. So we'll need to make lamps bigger, and each one of these then has to get smaller. Be able to write that down, right? So that I can understand it. Again, remember, I'm middle management, which means I don't know jack squat about anything. So you have to be explicit and say that the lamp pie piece will now be bigger. Every other piece will be smaller. All right? All right. So graphing. Again, you will have to do way more graphing than is really necessary on the homework. Sorry. but they're free points, so draw some pictures. If you got kids, let them draw on them too.
Are you sure?
I'll let my child do it.
I'll get it out to your grandkids.
All right.
Another child though.
So the last thing that we need to do, or to talk about then, are measures of dispersion. So, measures of central tendency are important because this gives you the middle, right, the average, where you can base all of your sales on one particular number. But to get a little bit more information about what does your middle number mean, you also will often display a certain amount of information about how spread out are my numbers, okay? So you can have an average, right? You can have an average of numbers that's like 100, but what could your numbers be? They could be 99 and 101, right? Because that averages to 100, or they could be 0 and 200. What you want to know is, well, give me a number that tells me how spread out are my numbers. So if all my numbers are really close to the average, it would be nice if you gave me a number that says, well, their dispersion is small, they're all kind of closely together. But if they're all spread out, let me know. All these numbers are spread way out, so give me a dispersion number that's larger that tells me I'm all spread out. Okay? Now, the first one that you will give with this is the sort of the easiest one to work with. It's the range. So often when you are dealing with statistics, you will tell people what the range of your values is. The range of your values is just the difference between your largest and your smallest number, okay? And that's at least a step in the right direction, right? Because if what's the range of these two numbers?
99 and 101.
99 subtracted from 101, it's 2, right? What's the range of 0 and 2? 200, right? So when you give people the range in those numbers, people can tell pretty quickly when the average is 100. If the range is 200, your numbers are, they can be pretty big. If your range is 2, you know that all your numbers are really close to 100, right? Because if the furthest away you can get is 2 units, they got to be pretty packed in there, right? So if there was more than 2 numbers in these, they would all be, hovering right in between there, right? Now, the other number that you give, the more standard term that you use to talk about dispersion, variance, and a term that hopefully you've heard before, maybe not though, standard deviation. Alright, so the standard deviation, the definition for the standard deviation is the average distance from the mean. That's kind of what it means. Alright? So in a really simpletons kind of way of looking at this, we could say, well, what's the average distance between these two numbers? Well, how far away is 99 from 100? 1. How far away is 101 from 100? 1. We could kind of say that our average distance from the mean here is 1, whereas the average distance from our mean here is 100. Much bigger number, okay? Now, as it turns out, you can't quite do it, which is mildly unfortunate. But you'll see here in a second. Alright, so let's start with a nice straightforward data set. and we'll calculate the variance and the standard deviation for these numbers, okay? Suppose I have 5 numbers and they're just 1, 2, 3, 4, and 5. Okay, so suppose I had 5 people in my class, I gave a 5-point quiz, and these are the scores that those 5 people got. Right? And now I want to know, first off, what was the average score in my test? Or what's the mean? 3, okay? Remember, when you have a variable with a bar over it, that's indicating the mean, right? That you should get used to that, or at least recognize it when you see it, because that's what people are trying to tell you. It's the mean or it's the average. Now, what I'm going to do is ask you to create a table to calculate these values, variance and standard deviation, because it's going to make your lives easier, okay? And the reason why is that the definition of variance, right? Let me not do it yet. I will show you why we do it here in a second. All right, so here are my 5 numbers, 1, 2, 3, 4, 5. And remember that standard deviation is kind of like the average distance from the mean, right? So how do we calculate distance normally? You subtract, right? So let's take each one of our numbers and subtract the mean. Okay? So take your number 1 and subtract the mean. 1 minus 3, negative 2. 2 minus 3, negative 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. Alright, now, normally, I would say, okay, calculate the average of these 5 numbers, right? Because this is the distance from the mean for each of our numbers. So if I told you to average these 5 numbers together, when you're averaging numbers, what do? Add them all up. When you add all of these numbers up, what do you get?
260.
Wait, do that again? You sure it's 0? It better be 0, folks. That's the freaking definition of average, right? The average is the number such that when you subtract it from each of the numbers and then add the value up, you always get 0. That's the definition of average, okay? So our problem kind of comes from the fact that we're going to always have some positive numbers and some negative numbers, right? So when we talk about distance in the physics world, what do physicists do when they say distance? Physicists always say that distance is a positive unit, right? So if I step a meter this way, it's 1 meter. If I step a meter this way, it's 1 meter. But one time I was going that direction, the other time I was going that direction. Yeah, we're still going a distance. It has to be a positive number. So what physicists often do is they say, well, just ignore the negative sign. What would a mathematician say to ignoring the negative sign?
Meet me in the alley.
Yeah, that's absolutely right, folks. We would get out implements of torture and utilize them, okay? Mathematicians do not like to throw away negative signs. Now, and the reason why we don't like it, and this is, don't write this in your notes, just sort of observe and understand a little bit, is that if you were to graph the removal of negative signs, normally when you just think about it as these are the positive values or the negative values of a number, this line just shoots all the way straight down. But what we did is we said, anytime we get a negative number, just make it positive instead. Okay? Just move it up. And the problem is, that little thing right there at 0, there's a point in our graph, right? A sharp point. Sharp points to mathematicians are really scary. They cause pain, right? Because if you get stabbed with a sharp point, what happens? You bleed, right? That's bad. We mathematicians are very sensitive people. Anyways, we don't like to have points. Now, what we do like though are nice smooth curves. We like curves. And the cool thing about this is the way squaring a number looks. Is it makes a nice curve instead of that nasty, scary, oh, I might bleed point. Okay? So what mathematicians discovered was that if, when you are determining what variance and standard deviation are, instead of just throwing the minus signs away, you square the number. When you take a negative times a negative, what happens? You lose all those minus signs, right? So what we do is we square them instead, okay? You do have to know how to square numbers. This is very good for you. Realize, folks, that all you're doing is squaring the number, and then whatever number you get, throw the minus sign away, okay? Because that's the whole point, right? So what is 2 times 2? 4. What is 1 times 1? What is 0 times 0? What is 1 times 1? And what is 2 times 2? 4. Okay. And now what we want you to do is instead average these numbers. Now, unfortunately, and again, this is because mathematicians are sneaky, you have to do a little bit of a twist to the average, okay? So the way variance is defined is that 1, what does this symbol mean again? What's this Greek sigma? The sum of, right? Because you've used a spreadsheet program, you know that's the button you hit to make Excel add up all the numbers, right? Same sort of thing. So this says, add up all of those squared values we just did. Okay, so take each one of our numbers, minus the mean, and square it. So let's add these numbers up. I made it easy so it wouldn't be tough the first time. It's just good old 10. That's our numerator, and when we go to figure out the average, instead of dividing by the number of numbers, we have to actually subtract 1 from the numbers, and that's because mathematicians know or discovered that when you're taking a sample of information, you have to take 1 away from your numbers to get a proper real average, okay? So, to calculate our variance, right, our variance for this example is the sum of all those squares, which is 10, and then divided by 1 less than my number of numbers. I had 5 numbers. I'll just write it out there, right? 5 minus 1. You guys can do minus 1 in your head. So 10 divided by 4. 10 divided by 4. Two and a half. So our variance for this set of numbers is 2.5. Well, that's kind of weird, right? Are any of our numbers 2.5 units away? Right? I mean, the furthest any of ours are away is 2. Well, this 2.5, well, that seems a little bit weird. Again, remember though, what did we do? We squared it. Oh yeah. How do you get rid of squaring something? How do you undo squaring? Divided by 2 is a good guess, but it's not quite right. Take the square root. So, in order to get the standard deviation, which is the average distance from the mean, guess what we do with the variance? Just take the square root. Yeah. So, one of the cool things about standard deviation is that it is the square root of the variance. So this is the only time in this class that you guys have to work with square root, which is why I make sure that we cover it, because you should know how to work with square roots on your calculator. So whatever kind of calculator you have, please make sure that you know how to generate the square root of 2.5. For these calculators, if you have this variation, it's just a button. Hit the square root button first. Note that it's right above the x squared button. So you have to use that little second function. But then type in 2.5. Technically close the parentheses, although you don't have to. And you'll see that our standard deviation rounded to the nearest hundredth is really 1.58. Can everybody get 1.58 on their calculators, taking the square root of 2.5? And those of you who do not have your calculators here, you will be able to do it. Okay. Put in the square root first. So second square root, and then 2.5, and then equals.
Mine, I just had 2.5 in that button and it gives me.
Depends on which version of this one you have. If you've got an older version, you can just hit the 2.5 first. Clear it up. Okay.
What button do you hit?
Okay, just hit it once. Now hit second square root. Oop, that's not hit over the squared button. There's two square roots, folks. Be careful. One of them has a square root with a little x on the top. Don't use that one. So second, which gets you to the second button, and hit x squared, which gives you the square root. Then put in 2.5.
There we go.
Oh, I got it, I had the wrong one.
Did you use the wrong one? Did you use the one above it? Yeah. This is why. There's a way to take a cubed root and a fourth root and a fifth root. That's what the button above it does. You guys don't have to worry about that yet. Oh, what? Yeah, I don't think you ever have to do anything other than square roots and count. It's a bummer. You might have to do a cubed root, though. You never know. Oh.
Yeah, I got it.
So everybody's able to get the 1.58? Again, some of you have to hit the square root button first, some of you don't. Again, it kind of depends on what type of calculator you have. Just make sure you know how to use it. Okay? Alright? Okay, cool. So, this is what we would call the standard deviation, and this is really what mathematicians would consider the average dispersion in this set. Okay? So it's about 1.5, right? And that sounds about right, right? Because some of our numbers are 2 units away, some of our units are 1, some of them are spot on. It averages to roughly 1.5. Alright, so let's try and calculate standard deviation and variance for another set of numbers, but this time let's make it a little bit more interesting.
Yay.
1, 2, 3, 4, 5 is, that's boring. Alright, so, let's see, let's figure out, so I love to use negative numbers, -1, 4, 9, 10, and let's at least keep it relatively reasonable, 12, what's the sum of those? 21, 31, 30, 34, and I want it divisible by 6, 34, I can't use 8, 14? Alright, so these are my 6 numbers. I gave you an extra number this time. Scary. And now I'm going to ask you to do the same thing here. Tell me what is the variance and standard deviation for this data set. Also, tell me what the range is. Okay, so I want to know 3 things, right? I want to know the range, I want to know the variance or the variation, and then the standard deviation. Again, do the easy stuff first. What's the range? That's the median. What's the range?
Negative.
15, right. And how'd you get 15 again? minus -1. Range is 15, right? Please remember how to subtract negative numbers. Very important. That's chapter 5. Alright, variance, we need a table. So, let's see that one up there. I think we've got enough room over here. So what do we need to do first? Find the mean, right? Remember that the number you're subtracting is the mean, and it's the mean, not the median, okay? So it's the mean of my numbers. I thought I made it work, right? Did you guys get for the mean? What's the mean show them? How do you calculate the average? What's the average of these 6 numbers? How would you do it? How do you figure out an average? Add them, and then what do you do? Divide by them. So add them up. What'd you get? Add all these numbers up, you should get 48.
Yeah, that's what I have.
And then you divide by 6,
Oh, okay.
because there's 6 numbers, right?
Yeah. That's what I have. We have 8.
8. Good. That's our mean. That's what we're going to subtract from each one of our numbers, right? So again, put your numbers down. -1, 4, 9, 10, 12, and 14. And then subtract the mean from each one of those, right? So -1 minus 8, 4 minus 8, 9 minus 8, 10 minus 8, 12 minus 8, 14 minus 8. Be careful with that. -1 minus 8 is -9. 4 minus 8 is -4. 9 minus 8 is 1, 2, 4, 6. And then square each of those numbers. Again, you got your calculator, so square 9, or 9 times 9, 81. 4 times 4, 16. Again, remember, you're squaring the negative sign, so they're going away too. 1 times 1 is 1. 2 times 2 is 4. 4 times 4 is 16. 6 times 6 is 36. Remember that the variance is the sum of those numbers divided by n minus 1. So add up all of our numbers. Does it add up to a nice number? What was that? 154? I'll buy it. Looks right, right? Everybody get 154? So 154. Again, there are 6 numbers up here. Divide by 6 minus 1. You guys can do 6 minus 1 in your head. That's 5. $154 divided by 5 30.8. That's our variance. Again, remember that is a squared value. To get our standard deviation, take the square root of 30.8. And again, round it to say the nearest tenth, that's fine. 5.7? What? 5.5, I'll buy it. 5 or 6. 5.5 is your standard deviation. So here, this is telling you that these numbers, because the standard deviation here is 5.5, whereas the standard deviation over here was 1.58. These numbers are more spread out from the number 8, which is their mean, than these guys are when their mean was 3, right? And if you look at the numbers, right, these are sort of pretty close together. These guys, yeah, I mean, they're close, but they're definitely further apart than these, and that's what this number tells you, okay?
So the variance is 30.8.
Yep. But the variance is always that, just divide it. 30.8, standard deviation, take the square root. And again, I will tell you on the test where to round the numbers, okay? All right, so this is all well and good, talking about dispersion, but how do we actually use it in business? The fact that a couple of you have heard the phrase standard deviation before, one, it should scare you a little bit, and two, it should make you a little curious. So what? Why do we care how dispersed our numbers are? Well, it turns out that this is a really important number when you talk about normal populations. Turns out, folks, we, as human beings, we're normal. I don't mean that to be disrespectful,
Compared to most of them.
but I'm normal. I swear I am. As long as you put me in a big enough group, I will not be noticeable. All right, normal populations. The way normal populations work it's where bell curves come from, okay? A bell curve is a population map. Basically what this is a line graph of the frequency for a normal population, right? And think of this as being, say, shoe size for an average, fully grown male. So what's the average shoe size for a guy? What do you guys think?
Size 10.
10, 10 and a half? Okay, so let's suppose that the average shoe size for a guy is 10. It's probably about right, all right? So if you randomly pick a guy out of the world of men that are fully grown in the world, on average, you're going to pick a guy who's got a foot size of 10. That's just the way it works, okay? Now, the question is, when you, as a shoe company owner or manager or something along those lines, how do you decide how many shoes of each size to make? How do you know? Do you make every size the same number? Do you make, 500,000 shoe size 7, 500,000 shoe size 7.5, 500,000 size 8, 8.5, 9? Doesn't make sense, right? Because how many people have a shoe size of 8 as a man? There's definitely some, but are there as many as that have a shoe size 10? No. So what do shoe companies do? They get this curve out and start using it. okay? The way it works. So let's suppose, and I have no idea if these numbers are right, but let's suppose that the standard deviation of a shoe size for a man is about a size and a half, okay? And that's probably pretty close to true, okay? So what statisticians have discovered is that if you take all the men in the universe and you say, okay, let's add one standard deviation. And folks, this is a standard symbol that means standard deviation. It's another Greek letter.
What is that?
It looks like a little squiggly, an O with a squiggle on the top of it. It's actually a Greek sigma. It's the lowercase version of sigma. You're going to learn some Greek in this class, whether you like it or not. It's good for you, right? But basically it means add one standard deviation. So 10 plus 1.5, 11.5. And if you subtract one standard deviation, minus sigma, 10 minus 11.5, 8.5. What statisticians have discovered %, all in the world of all men will have a shoe size between 8.5 and 11.5. So the majority of the shoe sizes that shoe companies will make will be between 8.5 and 11.5. So if you go to a shoe store and they actually have men's shoes there, which is rare, most of the shoes will be between these two sizes, right? So you have 8.5s, 9s, 9.5, 10s, 10.5s, 11s, and 11.5s. Now, if you go another standard deviation out, so subtract another 1.5, 7, add another shoe size, add another standard deviation over here, 13. This represents 95% of the world. So, if you are a full-grown man, and it turns out that your shoe size is 6.5, guess what?
You might not
You're
find
not
it.
buying a shoe.
You gonna go to the
Store.
boys section.
Better buy
Folks, I do more shopping in the junior section than I do anywhere else.
But then it should be cheaper.
In theory, true. Unfortunately, what kind of shoes do you get in the junior department? Yeah, I get SpongeBob SquarePants shoes. Which, I mean, you know, that could be a fashion statement. Yeah, exactly. So that my mom knows where I am at all times. Anyways, this is one of the things that definitely is used in the business world. And this is for all things people. Because, folks, we are really growth-wise normal, right? So, pants, shirts, hats, you name it. They're going to figure out what the average size is, what the standard deviation is, and play this game around it, all right? And the cool thing about it, folks, is that this graph, this bell curve, is symmetric. There's another great word. What does it mean to have symmetry? Yeah, it's if you fold it in the middle, everything will overlap itself, right? It's supposed to be the way we are, right? If you chop us right down the middle, lengthwise.
But one side is bigger than the other.
No, the other side, one side's the same as the other, supposedly.
Right.
Right, yeah. We're supposed to be symmetric. It's just that, you know, we get screwed up in the womb, and I blame my mom. It's always the mother's fault. Sorry, ladies. All right, so how do we use this? Well, the sorts of things that you can use. The cool part about it is that since it's symmetric, if this represents 68%, how much is right here?
34.
34, right? Because that's half of 68. This is 34%. This is 34%, right? Because that gets us to 68. How much is in there? What percent of the population is between 1 standard deviation and 2 standard deviations away? 47.5, but remember, I got
13.5.
13.5. How'd you get that?
I took 95 divided by 2 and then subtracted the 34%.
Right, so we know that there's 47.5% on each side, right? But that has to include the 34%. So you can take 47.5 and subtract the 34 to get you to 13.5. So, here's a question for you. What percent of men have a shoe size of 8.5 or larger? And be careful, right? How much is in here? What's missing?
5% missing.
There's still 5% missing, right? What percent are that way? How many are this way? So be careful, right? So in this case, 8.5 or larger, what are you going to do? Just add them up, right? So you can say 34, 68, 80, 68, 81 and a half, plus 2.5, 84. Is that what you guys got?
Yep.
All right, so what percent of men have a shoe size between 7 and 11.5? Huh? 81.5%. Alright, so these are the sorts of games that you play when you're dealing with standard deviation, right? Because it's really setting up how divided up is our population. And again, obviously in the business world, they would even narrow these down, smaller and smaller, right? Because they really want to know, well, what percentage are a half a shoe size away? And they would have to figure out, well, how much is a 0.5% or a half a shoe size away so I can get these percentages better. And then I'll say, oh, I will make, 60% of my shoes size 10, and then 20% of them size 10.5, and then 10%, etc. along those lines, all right? So this is why you use standard deviation, because it breaks up the world into a nice, normal little chunks. And folks, this is used everywhere, okay? Because the scary thing is that we are so normal, it's ridiculous. And again, so is a lot of the rest of the world, right? If you look at, plants are often growing at a normal distribution, right? I mean, some plants are big, but some of them are small, but most of them are about an average height. Again, same sort of a business, right? So, side note on the homework. There's a little addition that I want you to do some of the optional exercises. So do the standard ones, 2 through 22. On pages 545 to 549 or 548. And the optional exercises on page 549, do numbers 2, 4, and 6. This basically will give you some practice doing variance and standard deviation and playing around with this kind of stuff, okay? Might not be a bad idea to have this drawn on your notes for when you take the test.
Is Wednesday our test then?
Yeah, Wednesday next week.
Okay, that's what I thought.
We'll work on the computer.